Welcome to my Cisco Scaling Network. This is the third installment of the CCNA material. Here we're doing Chapter 8, which is the EIGRP Advanced Configuration and Troubleshooting. So we're going to be looking at three major areas: Advanced Troubleshooting, the Advanced EIGRP Configuration, Troubleshooting, and Summary. So really two areas: Advanced EIGRP and Troubleshooting. So again, our objectives are going to be talking about like summarization, both manual and automatic, propagating default routes, modifying interface settings, configuring authentication, explaining how the process works, and troubleshooting. So let's go ahead and look at our network topology that we're going to be using. Here is our EIGRP routing domain. We're going to probably have a default route to get to our ISP. So automatic summarization at a classful network boundary basically means we're going to be summarizing on that classful boundary, 8, 16, 24. That's going to be where we have a full octet full of ones, and we don't really like classful addressing anymore. So here we can summarize the subnets that are listed, these guys right here. Let's go ahead and switch to my pin. We can summarize these with a /16. That's kind of horrible because we don't have 4, 5, 6, 200, 250. So if we actually summarize these based off of their classful network boundary, we're wasting lots of addresses. But that's what we have to talk about first, so that's what we did. So for EIGRP, automatic summarization is disabled by default. To summarize, you can turn it on by doing an auto summary. To turn it off, you can do no auto summary. You can verify auto summarization by doing a show IP protocol, and it will tell you if the summarization is enabled or turned off. And it's going to be right here. Auto summarization enabled or disabled based off of the setting that you set up. We can also look at the show IP EIGRP topology with all links. And again, this is going to be one way to summarize it, because this is going to be the summarized address of the ones below them. Alright, so we can also look at them by show IP route, EIGRP. Again, you can see the summarization. That guy's not summarized, but that guy is. And that's one of the problems with doing this is we're summarizing larger address scopes than what we really need to. So how does a summary route work? First we start with a straight zeros. Then from there we send a routing update using a default route. 1, 2. We then will add the new route table via R1. We will now look at those. We will then update and summarize. So it will now get the route summarization to R2. We will now look at this and look at the information and then process it. Send it to 8. It starts looking at the default routes, starts looking at it has a routing loop, and then realize that there is an issue here with the routing loop. That's one of the problems with our summarization. So null 0 route is used for a loop prevention. Same general steps, but we also add in a via null 0. It will get this via R3. Notice it's still very similar, but here it's being learned via null 0. Let's go back one slide. Here it wasn't saying anything else, it was just This is what we're sending to R1. By adding in that via null 0, it adds that layer of loop prevention. Basically, when we go to do this and we go to send the router updates, this is what ends up happening. It has a summary route for 172.16.00/16 via null 0. It will drop the packets because it recognizes this as itself. You can manually summarize routes if you want to. EIGRP again can use summary routes whether you auto do this or not, because EIGRP is classless. Routing protocols include the subnet mask and the routing updates. So manual summarization can include a supernet route. Supernet is an aggregation of multiple major classical networks. Here we go. Here is our summary address, if we choose to do so. Here we're summarizing, which is going to be common on our subnet mask. That dictates what's going to be common on our IP. Verifying, again, show IP route. You can see the summarized addresses now. How do we do this for IPv6? Same general steps: summary address, EIGRP, the appropriate AS number, and then the appropriate summarized IPv6 address. So now that we're done with that, let's talk about redistributing or repropagating a default static route through the network. If we have an IP route that we want to distribute, we can add the command redistribute static, and that will redistribute our routes that are static routes into EIGRP. We can verify that again with the star will be the default candidate route. If we are looking at a D star EX, the D will be it's learned from that routing protocol. Star is the candidate for the default route. EX, this is an external EIGRP route. And then 170, because this is the admin distance for the external EIGRP. 170 is basically the default admin distance for EX. We can again do the same thing with IPv6. Similar commands, redistribute static, and that will allow us to do that. We can manipulate the static metrics if we chose to. Again, the K values, K1, 2, 3, 4, and 5. K1, 2, 3, 4, 5. We can look at the appropriate bandwidth, and we can manipulate bandwidth utilization. Underneath a interface, we can do a IP bandwidth percentage EIGRP and the appropriate AS number. That will allow us to control bandwidth percentages. Similar command for IPv6, except instead of doing IP, we do IPv6, bandwidth hyphen percent EIGRP, the appropriate AS number. Here's an example of our hello timers. Again, pretty similar to OSPF with the commands. Hello interval, except this time we're doing EIGRP, 1 and 60. EIGRP, that's going to be the instance number or the autonomous system number. So EIGRP 1, we use the hello timer of 60. The default hold timer is 80. The default hello interval is 60. Hello interval, hello time. Here are the defaults. If we're talking a greater bandwidth, we'd be looking at a default of 5 and 15, because again, the default hold timer is 3 times larger than the hello interval. One thing that I really like with EIGRP is it does allow for load balancing. So you can actually do up to 32 equal cost routes can be kept in the routing table, and you can do maximum path values. You can do load balancing based off of that. Show IPv6 route, which we've already discussed. Routing protocol authentication, very similar to OSPF, except this time we're going to be using the MD5 algorithm only, where with OSPF you could do a open, you could do a weak or a simple, or MD5. With EIGRP, you're kind of limited to MD5. So how do we set up the authentication? Sadly, this is going to be a little bit more work here. You're going to do a key chain, and you're going to name the key chain. You're going to do a key ID and a key string. Once you do that, you can set up the EIGRP using a key chain and a key. We do that by, again, going to the interface we want to do, setting up IP authentication mode, EIGRP, the appropriate AS number, and the MD5. Then IP authentication key chain, EIGRP, AS number, and the name of the chain. So AS number is going to match MD5 and the name of the chain. So let's look at that as an example. Here we have an EIGRP key. Let's go ahead and do key number 1. Here we have the key string, or the actual passphrase, as Cisco 123. Underneath our appropriate interface, we will set up IP authentication mode EIGRP 1. We're using MD5 authentication. Then the next command will be IP authentication key chain EIGRP. So this is where I get varying information. That should be the AS number. That should be the name of the key chain. Previous slide. AS number, then the name of the chain. So why is the number 1 highlighted? It is not part of that key chain. Authentication again, here we go, for IPv6. Pretty much the same thing, except it's for IPv6. Verifying the appropriate authentication, show IPv EIGRP neighbor, and show IPv6 EIGRP neighbor. That will give us the details that we need. Alright, let's get into our troubleshooting section. So for commands, for IPv4, the ones that are really big for EIGRP are going to be show IP EIGRP neighbors, show IP route, show IP protocols. For IPv6, the same commands, but for the version 6 variations of them. For the components, again, pretty straightforward with the appropriate flowchart. Connectivity issues is, are you able to contact your neighbor? Yes or no? If yes, is the routing table correct? Yes or no? Does it take the appropriate desired path? Yes or no? And you use the appropriate show commands, show neighbor, or show IP EIGRP neighbor, show IP interface brief, show IP route, show IP EIGRP interface, or show IP EIGRP interface brief, and those allow us to get through the different troubleshooting of why they're not. Verifying layer 3 connectivity. Are we able to ping one another? Are we able to look at the adjacencies? Here we're looking at a show IP interface brief to see the information between them. If we're wanting to look at the EIGRP parameters, it's going to be a show IP protocol or show IPv6 protocol. So this allows us to look at the specifics of it. We could be looking at its interface or an interface brief that gives us, again, its interface, its peers, reliability, its means SRT times. we could be show IP, looking at passive interfaces, verifying that we didn't actually do a passive interface on a WAN interface. That way we're not sending out writing updates because, again, we did passive interfaces on all of the interfaces. Here's how we set passive interfaces. You'd add the no front of it to turn it off. Always verify that you have the appropriate network statements and that they're working. Not sure why we needed 2 slides about that. How to add the missing network statements. You don't have to include the wildcard mask, but you should. Be wary of auto-summarization. Pay attention to auto-summarization. And that's actually Chapter 8 in a nutshell. So we have one chapter after this. If you have any questions, please let me know. Thank you.